Math 3, Unit 11, Spring Final Review. Unit 11 is over logarithms. So remember, throughout the logarithm unit, we were switching between exponential form and logarithmic form. So you can see here again that the base on the log goes to the base for the exponent. This answer part is the exponent, and this part right here is the answer in exponential form. So they go back and forth. So this first question, we can either put equals x, or we can write it as 2 to what power equals 16. So right there, I just changed this from logarithmic form to exponential form. If you know the answer, that's fine. If you don't know the answer, we want to get like bases. So 2 to the x equals, and 16 is 2 to the 4th power. And based on that information, we can see since we have like bases, your exponents also are the same. So therefore, the answer for this problem is 4. The next one, we can put equals x as well. And what that is saying is 7 to what power equals 1? Well, the only way to get an answer of 1 is for the exponent to be 0. And so this answer here is 0. The next problem, again, we can put equals x to change it easier into exponential form. This now is saying 7 to what power equals 1 over 49. Again, we want to get like bases, and so 49 is actually 7 to the 2nd power. And with the fraction, in order to bring them up so that they're at the same level, you would change this to a negative exponent in order to bring it up. And so we have 7 to the x equals 7 to the negative 2nd power, which means that our answer here is negative 2. Anytime we have a natural log, it is base e. And so again, we are saying e to what power equals 1 over e to the 3rd. We want to bring our e's up to the same level, and so in order to bring that up, it's going to get a negative exponent. So e to the x equals e to the negative 3rd exponent. Since our bases are the same, exponents are also the same, which means that my answer here is negative 3. Anytime you have a log equation and it doesn't state the base, it is base 10. So this is saying 10 to what power equals 1,000. You can count the zeros to let you know the exponent. So in order to get the base here, 10 to the x equals, and this is going to be 10 to the 3rd power, makes 1,000. And again, the 3 comes from the 3 zeros. If you multiply 10 times 10 times 10, you get 1,000. We have like bases. The exponents are the same, so that means my answer here is 3. Next, we will rewrite this again in exponential form. And so this is saying 5 to what power equals the cubed root of 25. We're going to want to get base 5. And so 25 is actually 5 to the 2nd power. So 5 to the x equals, and this is going to be 5. Now when you're dealing with exponents and roots, the exponent or power here goes on the top, and the root index goes on the bottom of the fraction. And so we have like bases, which means our exponents are the same, and the answer for this problem is 2/3. Next, it states, determine which 2 consecutive integers the following logarithm lies between. So again, we're going to change this to exponential form, and we get 3 to what power equals 41. Well, there isn't an exact power that 3 goes to give you the answer of 41 for this problem in terms of it being a whole integer. And so we're going to approximate. We know that 3 to the 1st is 3. 3 to the 2nd is 9. 3 to the 3rd is 27. Excuse me. 3 to the 4th power is 81. And I'm going to go ahead and stop there because the value of 41 would fall right in between 27 and 81. And so that means our answer, 3 to what power, is going to be somewhere between these exponents, 3 and 4. This says rewrite the logarithmic function in an equivalent equation. So an equivalent equation would be to change this into exponential form. And so that would be 4 to the y power equals x. So all I did was change this from logarithmic form to exponential form, and this is an equivalent equation. Remember, these can go back and forth and change. Next, they want us to solve for x, and we have 4 and 8. We want to change them so they have like bases, because if you have like bases, you have like exponents. 4 can be rewritten as 2 to the second power. Since you already have an exponent there of 3x, you multiply them together, so this is going to be 2 times 3x. 8 is 2 to the third power. And again, since we already have an exponent there, we multiply them together, so that's 3 times x plus 1. Now that our bases are like, that means our exponents are like, and so we have 2 times 3x equals 3 times x plus 1. I multiply, 2 times 3x makes 6x. We distribute here and we get 3x plus 3. In order to solve for x, I'm going to subtract 3x to both sides. The x's there eliminate. 6x minus 3x is 3x. 3x equals 3. We divide by 3 to both sides, and my answer for x is x equals 1. Okay, so we're going to go ahead and move on. Now we're going to talk about graphing. So when we talked about graphing logarithmic functions, we talked about shifting. Also, you can see that these graphs are kind of off here, so I would just cross this out, and then you're going to end up having to draw a graph here on the other side. So on this log equation, we know that our logarithmic functions, because anything to the 0 power equals 1, and so before the shifting there is a point at 1, 0, and you have an asymptote that is at x equals 0. But we're going to end up shifting these, and so this will shift to the left 1 and down 2. So this x right here that I originally marked is going to be left 1 and down 2. And my asymptote was at 0, and it's going to go left 1, and up and down is not going to change it at all, and so we can just do that there. So right now I can see that I have my asymptote, so my vertical asymptote is here, which is at x equals -1. I can also see this point right here is on my y-axis, and so my y-intercept there is at 0, -2. I am unsure where it's going to cross the x-axis, and so we need to find our x-intercept. So I'm going to go ahead and do this right here. So our x-intercept, when you're finding your x-intercepts, you're plugging in 0 for y and solving for x. And so in this equation, I'm going to plug in 0 for y equals log base 4 of x plus 1 minus 2. This x plus 1 is connected together, so I can't go 1 minus 2. So we want to get the log by itself. I'm going to add 2 to both sides. This eliminates. And I have 2 equals log base 4 of x plus 1. Most of the time when you guys see logarithmic functions, it's written this way. Log base 4 of x plus 1 equals 2. And maybe when you see it like that, you can tell, I'm going to move this up so you can see it better, is we want to change this to exponential form. And so when we do that, it's going to become 4 to the second power equals x plus 1. And then we would simplify. 16 equals x plus 1. Subtract 1 to both sides. And 15 equals x. So that means that my x-intercept is at 15, 0. And so you could kind of count and approximate. I know the graphs are kind of weird right here, but I'm just going to put a point here and mark it as 15. And then we can go ahead and draw our curve. So it's going to go something like that. I'm sure you can draw it much better than me. And so my logarithmic function looks like that. The domain, remember, is dealing with your x values. So the smallest x value is at -1. We do a parenthesis because it doesn't ever equal -1, but it gets very close, and then it's going to positive infinity. The range is dealing with your y values. And so in terms of the y values, my smallest y value is at -infinity, and then that goes all the way to positive infinity for the range. Okay, going over here on this second one to graph, this one is going to shift or translate right 3 and up 1. And so our original function, remember, we have a vertical asymptote at x equals 0 and a point at 1, 0. And so this is going to go right 1, 2, 3 and up 1. And that asymptote would move right 1, 2, 3, and again up and down is not going to change it. So right there we can see our vertical asymptote, which is at x equals 3. We can also see that because we have an asymptote here, the graph is never going to touch the y-axis, and so for the y-intercept we can write none. For the x-intercepts, again we're going to plug in 0 for y, and f of x and y work the same, and so I'm going to plug in 0 for y and solve for x. So again, this is my x-intercept. So 0 equals log base 4 of x minus 3 plus 1. In order to solve the log function, I'm going to subtract 1 to both sides. I get -1 equals log base 4 of x minus 3. Again, you might want to rewrite that to look like this. Log base 4 of x minus 3 equals -1, and flip it around. And then we're going to change this to exponential form. So this is going to be 4 to the -1 power equals x minus 3. When we have a negative exponent, this becomes a fraction, and so 4 to the -1 is actually 1/4 equals x minus 3. And to get x by itself, we're going to add 3 to both sides. And so this answer is x equals, and 3 plus 1/4 is 3 and 1/4. And so for your x-intercept, this is going to be 3 and 1/4, comma 0. We go up to our graph. This is 1, 2, 3, so 3 1/4 is going to be about right there. And then we're going to draw our log function. So based on this information, my domain, which is my x values, it starts there at 3. And again, we use a parenthesis because it never equals 3, but it gets very close. Goes all the way to positive infinity. And for our range, it is from -infinity to positive infinity.